As SpaceX prepares to launch the Tracers mission, let's go ahead and get an overview of this now.
Earth is constantly bombarded by the solar wind, waves of dangerous charged particles from the sun traveling at speeds over 1 million miles per hour. Our planet's magnetic shield, the magnetosphere, protects us from the brunt of this technology-imperiling force. But high above each of Earth's poles, there's one vulnerable spot in this shield, where solar wind is funneled straight down toward Earth and our technology, the polar cusps.
These solar wind energies can negatively impact power grids, radio communications, satellites, and even astronauts, which is why understanding its mysteries and its pattern is key to protecting our future.
To better understand these space weather effects, NASA is launching a new mission called Tracers. The two spacecraft will travel through the polar cusps to take groundbreaking measurements of magnetic reconnection, a process that occurs when the solar wind drags the sun's magnetic field into Earth's.
When the sun and Earth's magnetic fields collide, there's a tremendous energy release. The magnetic field lines snap and reconnect, creating new field lines. This process, known as magnetic reconnection, sends highly energized particles in new directions, including down toward the Earth. Reconnection is very difficult to observe directly because it occurs on small scale compared to the vast size of Earth's magnetosphere.
Magnetic reconnection happens in various places throughout the magnetosphere, but it is most easily studied at the polar cusps. When the solar wind slams into Earth's magnetic shield, it's here at the cusps that the impacts reverberate. By flying through the polar cusps, tracers will be able to directly study the signatures of magnetic reconnection, helping scientists better understand and prepare for the impacts of space weather on Earth.
LD is go for launch.
And with a good go for launch call, we are now a little more than 30 seconds away. So we're going to step back on our commentary and listen in with you this final.
T-minus 15. T-minus 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go Tracers. Typically needs to go about 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth.
And a little more than a minute and a half into the mission, as you have heard and can see, everything is moving along nominally with the beginning of separation. And then the booster is going to perform a flip maneuver. The engine on the second stage will reignite as the boost back burn begins. Let's listen in.
Main engine cutoff.
Stage separation confirmed. I'm back startup.
Stage 1 boost back startup.
And there we heard callouts for the successful main engine cutoff, stage separation. Saw that stage 1.
Stage 1 landing burn.
Stage 2 terminal guidance.
Stage 1 landing leg deployed. Stage 1 landing confirmed.
Stage 2 Tracers SV2 separation confirmed.
And there we have it, successful deployment of the first of 2 Tracers satellites, and a beautiful view on screen there. Our next deployment will be the second Tracers satellite in about 4 minutes. So we're going to take a quick break. We'll be right back for our final deployments of the mission, and we'll see you soon.
Tracers SV1 separation confirmed.
There we heard confirmation of successful deployment of the second Tracers satellite. Beautiful live view on your screen. As a reminder, these twin satellites will measure magnetic reconnection, a record-breaking 3,000 times, helping scientists better understand and prepare for the effects of the sun on Earth. Now, we have one more deployment sequence to go, which includes the Athena Epic, LIDE, and Skycraft payloads, deploying in a little under 4 minutes.